Hey there, welcome back to my channel where we make science easy. In our previous videos we explained long division examples with answers. You can watch them here. But in today's video we will explain Newton's first law of motion, or the law of inertia, in science. So let's get started. Number 1. Law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. When no forces are acting on an object, it will remain at rest, or in motion with a constant velocity. Inertia is the tendency of an object to resist changes in its state of motion. The greater the mass of an object, the greater its inertia, and thus the greater the force required to change its motion. In other words, mass is a measure of inertia. For example, a bowling ball has much more inertia than a tennis ball of the same size, because it has a larger mass. Therefore, it takes much more force to change the motion of the bowling ball than the tennis ball. No. 2. Object at rest. If an object is at rest, it will remain at rest unless a net external force acts on it. This means that if an object is not moving, it will not start moving unless something pushes or pulls it. For example, a book resting on a table will remain at rest as long as no force is applied to it. However, if someone opens the book or slides it across the table, the book will start moving because a force has been applied to it. Another example is that a soccer ball will remain at rest on the ground until a player kicks it. No. 3. Object in motion. If an object is in motion, it will continue to move with the same speed and in the same direction unless a net external force acts on it. This means that if an object is already moving, it will keep moving at the same speed and in the same direction unless something pushes or pulls it. For example, a train traveling along a straight track will continue to do so at a constant speed, unless a force such as friction from the brakes or resistance from an incline causes it to slow down, speed up, or change direction. Similarly, a hockey puck gliding on a frozen pond will continue to glide indefinitely, unless acted upon by an external force such as friction from the ice or air resistance. Number 4. External forces. To change the state of motion of an object, a force must be applied to it. The force required to change the motion of an object is called an external force. External forces are forces that act on an object from outside the object. Examples of external forces include gravitational force, frictional force, tension in a rope, or applied force, such as a push or pull. For example, to push a shopping cart across the floor, you must apply a force equal to or greater than the frictional force opposing the motion of the cart. Similarly, to lift a heavy box off the ground, you must apply an upward force equal to or greater than the downward pulling force of gravity. The change in motion of an object due to an external force is described by Newton's second law of motion, which states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This means that the greater the force applied to an object, the greater the acceleration of the object. And the more massive an object is, the less it will accelerate under the influence of a given force. No. 5. Practical implications. Newton's first law has several important practical implications in our daily lives, and in various fields such as engineering and physics. Some of the practical implications of Newton's first law are as follows. Seatbelts in vehicles. Seatbelts are designed to keep passengers in a vehicle during a collision by providing an external force that opposes the motion of the passenger. During a sudden stop or collision, the passenger's body tends to continue moving forward due to inertia. However, the seatbelt applies a force to the passenger that brings them to a stop, reducing the risk of injury. Sports. In many sports, athletes must overcome their own inertia to perform effectively. For example, a sprinter must exert a large force on the ground to accelerate their body from rest to a high speed. A baseball player must swing the bat with sufficient force to overcome the inertia of the ball and send it flying. Space travel. In the vacuum of space, where there is no air resistance or other forms of friction, an object will continue to move indefinitely once set in motion. This means that a spacecraft can travel for long periods of time without any significant change in velocity. For example, the Voyager 1 spacecraft launched in 1977 is still traveling through space and has not slowed down significantly despite covering a distance of over 14 billion miles. Skating on ice. When a hockey puck is placed on a frozen pond, it will continue to glide indefinitely unless acted upon by an external force, such as friction from the ice or air resistance. This is because the smooth surface of the ice reduces friction, allowing the puck to maintain its motion for a longer duration. No. 6. Connection to other laws. Newton's first law is closely connected to his other laws of motion, particularly Newton's second law, which provides a mathematical description of the relationship between force, mass, and acceleration. Newton's first law provides the foundation for Newton's second law, which states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. This means that the greater the force applied to an object, the greater the acceleration of the object, and the more massive an object is, the less it will accelerate under the influence of a given force. In summary, Newton's first law of motion, or the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law highlights the concept that objects tend to resist changes in their state of motion, and that a force must be applied to change that motion. Newton's first law is a fundamental principle in classical mechanics and has wide-ranging implications in various fields, such as engineering and physics. Understanding this law is essential for comprehending the behavior of objects in motion and for developing technologies that rely on principles of mechanics. And that's it. If you learned something new, please share it with your friends and family. Also, don't forget to subscribe for more science lessons. Thanks for watching. See you next time.